Hello everyone, this is your video with practice problems for the Engel addition postulate. I am going to do the first couple here, 7 and 8. I'm just going to walk you through those, and then I'm going to give you a chance to try numbers 9 and 10 on your own, right? At least try to set those up on your own, see how you do with those, doing the drawings and setting up the equations and such, all right? So let's go ahead and jump into it and look at number 7. So 7 says P lies in the interior of RST. I'm going to do my drawing over here on the right just because I'm out of space. I don't have a whole lot of space on the actual problem. Okay, for all of these, first step is always to draw the picture, even if it seems, for a question like this, like if it seems a little silly, especially with angles, it helps because you want to make sure that you're drawing things like and putting things in the right spots, right? It'll help you with like the adding versus subtracting, okay? So P is in the interior of RST. Notice I just put it somewhere. It doesn't have to necessarily be right in the middle. Okay, they said RSP is 40 and TSP is 10, and they want to know RST. They want to know the whole thing. So this is a pretty simple one. This is just some straight addition. So angle RST, that's the whole. And then I have my two parts. RSP is 40. Right, that's one part. Plus my other part, 10 has to equal the whole thing. Part plus part equals whole. Okay, so this one's just some simple addition. Angle RST is 50 degrees. Right, simple as that. Okay, all right, let's take a look at number 8. 8 says ray QS bisects angle PQR. Okay, so you see that magic word bisect, right? So what that means is that the two parts that they give us will be equal. Okay, so I have P, whoops, let's erase that because that's an R, not a P. Whoops. Okay, so I have angle P. Sorry, everybody. I'm messing up with my mouse here. So PQR is your big angle, and QS is the ray, so that means S is the point here in the middle, okay? They say PQS equals 3x. Okay, so PQS is 3x, and RQS, which is down here, is 2x plus 6. Okay, now notice they didn't give me a whole thing out here, right? But I don't really care, not all that much, right? Because I have this magic word bisect right here, okay? Which means I know that these two expressions right here have to be equal to each other, okay? Remember, that only works if you have that magic word bisect or the magic word midpoint if you're dealing with a segment, okay? And really, I only want to use this, this method or this strategy when I'm dealing with two different expressions. Because if I have two of the same expressions, obviously they're equal because they're exactly the same. Okay, so let's just do some algebra quickly. This is a pretty simple one. I'm going to subtract 2x from both sides. So I just get that x is equal to 6, right? Boom. Now I have to quickly look and say, okay, did I answer the question? And the question is, what is the measure of PQR, which is this right here. So I have not answered the question yet. All I know is that x is equal to 6. Well, if x is equal to 6, then PQS has to be 3 times, right, 3x, 3 times 6, which is 18. Okay, so that means my other one is also 18, RQS. So this is 18, and this is 18. So angle PQR is 2 times 18, which is 36 degrees. Okay, so now I'm done. Now I've answered the question that they asked. All right? Okay, so taking a look ahead at number 9, I'm going to give you some tips to start, and then I'd like you to try it on your own. Okay, so pause it and try it on your own. Okay, so notice that they say y lies in the interior. Okay, so that we don't have that magic word bisect, right? So I know this is going to be a part plus part equals whole problem. Part plus part equals whole. Okay, and you're going to have to do some algebra here. And the other thing I want to point out to you is that it says that we're not just looking for x. I want to know what all 3 of those angle measurements are. So once you solve for x, you'll have to plug x back into all 3 of these up here. 1, 2, 3, in order to figure out what the angle measurements are. All right, so give this one a try on your own. I'm going to write some stuff out, and I will see you back here in a second. All right, folks, so here's number 9 all worked out. Go ahead and check your answers against mine. So in my lovely drawing here, I have y in the interior of angle ABC. So ABC is my big angle, and then y is that point somewhere in the middle. They said ABY is 2x plus 2. So that's this right here. Okay, they said YB is equal to 3x. YBC is equal to 3x. So that's right here. And then the whole thing, ABC, is equal to 6x minus 3. So I know since I have 2 parts and a whole thing, I need to add those together. Part plus part equals whole. So that's what we did right here in the middle of your screen. First thing I did was combine my like terms on the left-hand side. 2x plus 3x is 5x. 5x plus 2 equals 6x minus 3. Then now you're just into some algebra, right? I drew the line down the middle, which you don't have to do if you're pretty good at algebra. But if manipulating variables is something that you struggle with a little bit, this is a tool to help you to make sure that you don't subtract the 5x twice on one side of the equal sign instead of doing it on one on each side of the equal side. So you want to have one on each side of the line. So I subtracted 5x, and then I added 3, so I got x is equal to 5. But if you look back at the question, that's not what they're asking me for. They don't want to know what x is. They want to know what the individual angle measurements are. So you have to plug it in. Okay, plug it in, plug it in. Okay, which is exactly what I did right here. Okay, so wherever I saw an x, I plugged in 5. So for ABY, you have 2 times 5 plus 2, which is 12. For YBC, you have 3x, so 3 times 5 is 15. And then for ABC, you can do this one of 2 ways. You can either say, plug x into the expression they give you, so 6 times 5, 6x minus 3 is 27, or since I know that ABC is the sum of its 2 small parts, you can just add the 2 parts together, and you get the same thing. All right, so I need to clear my screen, and then we can try the next one. But I'd love for you to try this one on your own. So you have here this magic word bisect, right? So make sure that you know how to do things with bisectors, right? We have that special property that the parts are equal. Okay, so you will need that. You will need that knowledge in order to do both part A and part B. Okay, whatever you use in part A, you won't use again in part B. It's the same like drawing, but they're giving you different numbers and stuff for the 2 parts. All right, so give this a try, and I'll see you back here in a second. All right, folks, so here's number 10 all worked out for you. Check your answers against mine. So here they said ray FL bisects angle AFM. So AFM is my big angle, okay? In part A, we have LFM, which is one of the parts, equals 11x plus 4, and AFL, which is the other part, equals 12x minus 2, okay? Because we have that magic word bisect in there, and I have 2 different expressions, I can set them equal to each other, because that's what bisect means, 2 equal parts, Okay, so I have 12x minus 2 equals 11x plus 4. I subtracted 11x and added 2 to both sides and got x is equal to 6. Then they want to know, okay, so how big is LFM? And then how big is the whole thing, AFM? Okay, so for LFM, I just plugged x right back in, right? I took 6 and I plugged it right in wherever I saw an x. So I got 70 degrees for angle LFM. Now for angle AFM, I don't have an expression for it, but I do know that it has to be double whatever the part was, right? Because there's two parts, add them together and you get the whole thing, right? So if each part is 70, 2 times 70 is 140. So you have 140 degrees for the big angle, all right? Let's look at part B here, which same drawing, but with different expressions, different numbers, okay? So in this one, they have angle AFM, which is the big one, the whole thing, equals 6x minus 2, and AFL equals 4x minus 10. So when I originally drew this, down here at the bottom, all I had was this, the 6x minus 2, and this, that AFL is equal to 4x minus 10. But because I have that magic word bisect in there, right, I didn't have LFM. I didn't know what it was, which is why I put this kind of light blue box around it. I had no idea what it was, but because I'm dealing with this with a bisector here, then that means these two parts have to be equal to each other, meaning that I can write the exact same thing in both of those spaces. So that's exactly what I did, right? 4x minus 10 here for this part, so this part has to also be 4x minus 10. And now I have enough for part plus part equals whole, which is exactly what we did right here. Okay, so I have my two parts, 4x minus 10 and 4x minus 10. If you wanted to, you could have written this as 2 times 4x minus 10 equals the whole thing. I'm running out of space, so I didn't write it, the 6x minus 2. You would get the same answer either way, right? So I combined my like terms, and then I did some algebra. So I subtracted 6x from both sides, added 20 to both sides. Then I got 2x equals 18, so x is equal to 9. And then they wanted to know what angle LFM was, right? And in my drawing over here, LFM is 4x minus 10. So I took my x value, 9, and I plugged it in wherever I saw an x in the expression. So 4x, 4 times 9, is 36 minus 10 is 26 degrees. All right, you all, that is it for angle addition, right? And that's it for this week. So this is the last video for concepts for this week. Congrats, you made it to the end. Let me know if you have any questions or if anything that I wrote here isn't clear so that I can help you with that if it's something that you are getting stuck on. All right, I will see you all in the next video. Bye, everybody.